Hi. So today in this video, we'll talk about the question. So we want to ask that given some price and some wealth, this pair, and a worsening demand, given this price and the budget W. So we want to ask that can we know or can we infer that whether the underlying preference it is rational or not? Okay. So previously in the second chapter of the textbook, we have introduced the warp, right? So given some worse and demand function which satisfies the weak axiom of the revealed preference, okay, and that is sort of a weaker version of the something that we're going to introduce today, which is the stronger version of the axiom on the revealed preference. Okay, so and they are equivalent to each other when the dimension is 2, but beyond the dimension of 2, then this stronger version will be the SARP will be stronger than the warp. Okay, so for a recap of the warp for the weak version, so let's have a very brief review on this warp. Okay, so that goes back to the definition of 2.f.1. So we say that for a worse and demand x and pw, so this satisfies the weak axiom of revealed preference okay, warp in short. So if the following holds, okay, if for any two price and wealth situations, or just the price budget parameters, right? P, W, and P prime, W prime. So what we are going to have for warp is that if P inner product X, when this is taking P prime and W prime, so this has to be satisfying the initial budget, okay? And where they are not the same. So given P, W prime, P prime, and this has to be not the same as X, P, W. Okay, then what we have is that P prime inner product X, P, W. So this is strictly greater than W prime. Okay, so this is the warp, and it's not very straightforward to capture the key idea of this, right? So let's have some interpretation of this. So intuitively, we want to have some thing for this warp is that, so now if this is true, okay, so if P inner product X taking P prime and W prime, if this also satisfies the initial budget W, and we also have this, okay. All right, so if we have those, then we know that, when facing the price P, okay, and wealth W, the consumer, or we choose the consumption bundle P, X, W, even though the X, P prime, W prime is also affordable, right? That's what we're talking about here. So even if this, given P prime and W prime, even if this worse demand is also available or it is also affordable, we don't choose that, Okay, so now, okay, we can expect that the consumer to display some consistency, okay, in this sort of the demand behavior, okay, or in this preference behavior. So, or in the revealed preference, okay. So what do we mean by this consistency? So it means that given the revealed preference, okay, we want to expect that the consumer will choose XPW over XP prime W prime whenever they're both affordable, right? Whenever both affordable. If so, bundle XPW, okay, must not be affordable at P prime, W prime, right? Where the consumer or we choose XP prime, W prime. Okay? So, and that means as required by the warp. So we must have this P prime in the product XPW. This had to be greater than W prime. Okay? So that was the intuition for the warp. Okay? All right. So today we'll talk about a stronger version of that, of the revealed preference, which is called the strong axiom of revealed preference, which is SARP. Okay? And then we'll see the difference between those two. Okay, so that goes to the definition on the textbook 3.j.1. Okay, so say that the market demand function or the worst demand function XPW satisfies the strong axiom of revealed preference SARP. Okay. So now we do not only have two elements or two entries of those parameters with the price and budget. Okay. Now we're gonna have a full list of those. Okay. There are multiple of those for any list. So P1, W1, P2, W2, up to so on and so forth, up to Pn, Wm. Okay, so we have some requirements on this list. Okay, where so the close to, so adjacent to ones, they're not the same. Okay, so the adjacent to entries, they're not exactly the same in this list. Okay, for all n less than or equal to n minus 1. Okay, and something more important is that we have Pn inner product X P1 W1 greater than Wn whenever we have P n, so this is capital N, this is small n, P n X P little n plus 1 Wn plus 1 less than or equal to Wn for all little n less than n minus 1. So this requirement looks very long, and essentially it's saying that for those little n's, okay, for those entries noted by this little n, which is not the last one, okay, for all those previous ones, which is not the last one, then whenever we have this satisfied, so it means that if we use the price for the nth entry and the W for the nth entry, and if we use the solution for the taking the price and W for the n plus 1 entry and use that worsen demand, and that has to be satisfying or less than or equal to this budget, right, for the previous one. Okay, so, and that has to be true for all those, the other ones, which is not the last one, okay? Whenever this is true, then we must have, so this is saying that for if we put, so this is simply referring to the last one, okay? If we use this solution, this consumption set for taking the price, the first price and the first budget, P1 W1, if we take that, and then this has to be exceeding the budget for the last parameter, for the last set of Pn and Wn, okay? So essentially here, we can imagine this list, right? So for all the, so it's like a recurrence pattern here, but it's just that for the last one it's not, right? So all the other ones except the last one, we have this requirement satisfied. But for the last one, and when we're gonna compare that to the first one, and it doesn't satisfy this, and it has to exceed this. So it means that we're gonna break this recurrent pattern here. Okay, so that'd be useful for us to prove the transitivity in the rational preference. Okay, so that'd be a very important assumption. Okay, good. So this is the definition for the SARP, for the stronger version of the axiom of review preference. Okay. All right. So in other words, if, okay, so in this SARP, if the XP1 W1, it is directly or indirectly reviewed preferred to XPN WN, then this, I mean capital N, okay, then XP capital N W capital N cannot be directly reviewed preferred to XP1 W1. Okay, so XP1 W1 cannot be affordable at XPN WN. Okay, so let's have a further note on this. So if XP1 is either directly or indirectly. So directly means that we compare any two bundles directly, okay, to each other, and indirectly means that we want to have this chain and want to transmit this through a chain and to compare them indirectly. Okay, either directly or indirectly reviewed preferred to the last one, XP and WN, then XPN WN, it cannot be directly reviewed preferred to the first one, right? Okay, so xp1 1 cannot be affordable at the last price and budget. Okay. All right. So that's the definition and this intuition for this stuff for this SARP. Okay. So and then we're gonna introduce this proposition 3.j.1, and that'll be used for us to show to establish this SARP, the strong version of the revealed preference axiom, and relate that to a rational preference. Okay. So this goes to the proposition in 3.j.1. Okay, so we say that if a worth and demand function xpw satisfies the strong axiom of revealed preference, then there is a rational preference relation that can rationalize the worth and demand. Okay. So what do we mean by this rationalize? So that is such that for all the price and wealth, if P of P and W, X, P, and W is strictly preferred to Y for every Y which is not X, if this Y satisfies this budget requirement. Okay. All right. So, and then we're gonna prove this. Okay. Okay. So first we define a relation, okay, which is a binary relation. This, and we have a little 1 on top of this. Okay, so that's a binary relation on the commodity vectors where we want to let X preferred or X better than Y whenever X and Y are not the same. And what else? And we have X to be the worth of demand and Y satisfies the budget for some price and wealth. Okay. Okay, so this is still straightforward. Okay, and then this relation, this little 1, this relation can be read as directly revealed preferred to. Okay, directly revealed preferred to. Okay, so that is talking about this. Okay. All right. So from this relation, number 1, okay, from this we define a new relation, okay, with 2 to be read as either directly or indirectly revealed preferred to. Okay, so where we're at, if we're gonna say that X is preferred to Y, directly or indirectly revealed preferred to Y, whenever there is a chain, as we did before, right? In the SARP, there's a chain where we're gonna have x1 better than x2, but here we're gonna use this first version of this binary relation, okay, and so on and so forth. Okay, and the first one will be x, and the last one will be y. Okay, so that'll be the first. That'll be the second relation that we're gonna define using the first one. Okay. So the next thing is that we're gonna observe that. So by the construction, okay, as we hear, we simply use the transitivity to construct the second one, right? So the second one has to be transitive. Okay. Also, according to the SARP, this second relation, it has to be irreflexive. Okay, so E, x cannot be better than itself. Okay, and then we use so-called Zorn's lemma. Okay, that is, we can just take it as given. So this Zorn's lemma, which is some axiom of some set theory, okay, based on some binary relations. So it says that every relation, okay, here we define for the second relation here, that is both transitive and irreflexive. Okay, so if we have both of those, then we can call this binary relation to be a partial order. Okay, and we can often see this in some papers. So if that is transitive and irreflexive, okay, so this relation has a total extension, and this total simply means it's complete. Okay, and those are just for the preference relation, the rational preference relation, right, that we're gonna get. So a total extension, we call this as the third version of this relation. Okay, so every relation, the second one that is transitive and irreflexive, has total extension, and then n irreflexive and transitive relation such that first x better than y in the second relation implies x better than y in the third one. Okay, so that'll be the first. And second, whenever x and y are not the same, we have either x is better than y in the third relation, or y is better than x in the third relation. Okay, so the second one here is simply just for us to define our weakly preferred preference, right? Weakly preferred relation. Okay, so finally we can define the preference relation because we have the indifferent, right, included in this preference relation. So we need to have to exhaust all the possibilities here above, right? So we can define this preference relation by letting x keep equal to y whenever x and y are the same, or x and y are indifferent, right, or the same, or x better than y using the third relation. Okay. Okay, then it follows that this preference relation is complete. So because that in the Zorn's lemma, so it gives us this complete, not complete, it gives us this so-called total extension, right? So it's just another name for the complete. So it is complete and transitive in the XPW greater strictly prefer to y whenever y is satisfying the budget and x and y are not the same. Okay. So this proof is basically just a construction from the stronger axiom of the review preference, right? So from here, then we reach the rational preference that we normally see previously. Okay. Good. So this would be the stronger version, right? And we can see some difference between the stronger version and the weak version is that in the stronger version we require sort of the this chain, right? And it's like a kind of a recursive closure of the weak axiom, right? So SARP is a recursive closure of the weak axiom warp. Okay. All right. So okay. And later in the exercise in the textbook, and you see that in exercise 3.j.1, if you see this exercise, then you're gonna show that this warp is equivalent to the SARP whenever the dimension is exactly 2. Okay. Okay, so warp is equivalent to SARP if there are 2 dimensions. Okay. But if L is greater than 2, then SARP is a stronger version. Okay. And we're not going to prove this, but you could refer to the exercise and the textbook for further reading on this if you're interested in this. Okay. So, in the proposition 3.j.1 we just proved, it essentially tells us that, so proposition 3.j.1 tells us that a choice-based theory of the demand, okay, which is founded on the SARP, is essentially equivalent to the preference-based approach or preference based theory of demand that we discussed in this third chapter, right? Okay, and then here we have another connection between the PBA and CBA, right? Great. So that'll be everything for this episode, and today we discussed, we had a recap on the warp, and it had an introduction on the stronger version of the axiom of revealed preference, and showed to how to construct this rational preference using the stronger version of this axiom. Okay, and also discussed the relationship between the warp and SERP. Okay, good.